of lakes and ponds in the winter region. So you can see at the point whereby we are having the -1 degree. So you realize in this winter we have this one as ice. Now when we are having ice, it is because of the 0 degrees. So it is below 0 degrees. This one we are having the ice. But now below it, as the water continues to cool, it is losing the density because it is becoming less dense. Now that one happens up to the 4th degree Celsius, whereby you realize at the top you may assume that the topmost is solid because it is an ice, only to realize that it is going to be water as you continuously move downwards. And that's the reason as why you realize in these areas we still have some aquatic animals which are normally using the same phenomenon. Now, when we go back to our graph, when we want to plot a graph of volume against temperature of water, we are going to obtain this kind of diagram, whereby we say at 0 degrees, the volume is a little bit high. This volume decreases until the 4th degree. Now, at the 4th degree, this is where the water has got the lowest volume. Now, again, from there, it starts to rise, or the volume starts to rise with an increase in temperature until 100 degrees. So this is the reason as why we can see now it is forming an abnormal curve, which should not be, which is normally not common to all components. Now, from the formula, we know that volume, from volume, and then if we have the mass constant, we can now get the density, whereby we say that density is equals to mass over volume. Now, since mass is constant, how can we refer to density? Now we say, again, when the volume is lowest, remember we said that density is equals to mass over volume. Now, meaning that whenever the volume is lowest, when we are having the least volume, that is the point that we are having the highest density. And that is why you can see at the 4th degree, the density of the water is maximum, that is at 1 gram per cubic centimeter or 1000 kilogram per cubic meter. So we say that the distance, now when we sketch a graph, we are going to obtain a graph of this kind, meaning that the highest density is obtained at 4th degrees Celsius. Now this abnormal or anomalous expansion of water leads to formation of icebergs, which pose a great danger to ships, because the ships sometimes it knocks them, knowing that it is maybe a rock, and then it causes weathering in rocks, since water traps can freeze and expand in that area. Anomalous expansion of water now is generally normally defined as the unusual behavior of water in which it contracts when heated and expands when cooled. This one only happens between the degrees of 0 to 4 degrees. Therefore, and we have seen how the graph is likely to be when it is plotted. Now, we can now understand some of the instruments which are normally used we can now understand some of the instruments which are normally used in measuring this, and one of them is the thermometers, whereby we say that the thermometer normally has got a liquid, whereby we say that some of the properties of this liquid must be one, it must be seen, visible, it must contract and expand uniformly. Now, it should not be sticking on the side of the test tube, meaning that it should not be wetting glass, and should be having a wide range of temperature. Now, after this, we are now going to check on some of the common features that exist in thermometers. So as we said, that we normally have the lab thermometer and the clinical thermometer. So this thermometer is the clinical. This is the one which are normally used by the doctors, and this one is normally the thermometer that we normally use in our labs. So these ones, they are normally different. They have common features, same as well as they have similar features. So some of the common features is that they have the bulb, and you can see this one is the bulb, this one is also the bulb. They also have the scale, you can see the scale and the scale, and among the others. But now the major difference is that this one is normally shorter compared to the laboratory thermometer. because it is having up to a reading of 40. So it is having from 35 degrees Celsius to 43 degrees Celsius, while this one is having, the lab thermometer is having 0 degrees Celsius to about 110 negative. We have negative 10 degrees Celsius to 0 to 110 degrees Celsius. So those are some of the common differences that we have. And also this one normally have got a constriction. This constriction normally helps in maintaining the temperature that has been obtained from the body of a human being. So this constriction normally help in maintaining that temperature. Therefore, when we are dealing with the reading in this, we can now ensure that we have the temperature maintained, because it can still be withheld. Now it has got other features such as this. It has got a bulb, it has got a capillary bore, it has got a glass stem, which is normally helping in magnifying the reading on the scale. And the capillary bore is also helping in the rising or lowering of the liquid level, that is the mercury. Having learned this, we now say that we can conclude that the thermometric liquid that are normally used are normally mercury, alcohol, and then oil of creosote. So these are some of the commonly used liquid in thermometer. So we call them thermometric liquid, whereby the properties we have well highlighted. So the major difference between mercury and alcohol are: 1, mercury has a high boiling point of 357 degrees Celsius, while alcohol has got a low boiling point of 78 degrees Celsius. It is having a relatively higher melting point of negative 39 degrees Celsius, and it has got a low melting point of negative 115 degrees Celsius. Remember, mercury is a good thermal conductor, while alcohol is a poor thermal conductor. Then mercury expands regularly, and then alcohol expands slightly irregular. And then mercury does not wet glass, while alcohol wet glass. So these are some of the differences between mercury and alcohol. This one now marks the end of our chapter. Therefore, we say that chapter of heat transfer is complete.